And we are live. I'll give it a minute to let some people trickle in, but we'll be shortly beginning the webinar on the CrossChain library with myself and Connor.
All right, excited.
Seems everything's working well. YouTube is live. Other channels should be live as well. Excellent. So let's give it another few seconds for people to come in. Okay. Looks like we're in a good place to start. So, yes, first of all, welcome everyone to today's webinar. We'll be looking at the CrossChain library. And CrossChain was created by Cordial Systems as a key component of our middleware in being able to quickly add any blockchain to our MPC wallet. And now the library itself, we have open sourced. So we'll run through an example of how to use it and see how you yourself could add any blockchain in just a day or two rather than the industry standard of several months. And if you do want to try CrossChain in the context of our wallet, then you can request sandbox access from marketing at cordialsystems.com. That's marketing at cordialsystems.com. And we will give you access to use a testnet version, and you can try out any chain additions you may want, hopefully putting into practice a few things you'll learn today on the webinar. So first, we'll begin with some introductions. For those who don't know Cordial Systems, we offer a self-hosted MPC wallet used by everything from traditional stock exchanges, bringing capital markets on chain, to large trading shops like Jump Trading Group. We also have a lot of crypto native firms like Swissborg, Backpack Exchange, and for all of these guys, fast chain support is incredibly important. And my name is Seb, one of the co-founders over here, and I've been working in digital assets and custody for many years. But I won't be the one steering the conversation today. That will be the distinct pleasure of Connor, who I'll hand over to introduce himself before we get into the content.
Hello, I'm Connor. I'm the CTO at Cordial Systems. Been very involved with all of our technology, and I know quite a lot about a lot of different blockchains and their differences and their strengths, from the low-level technical details. So I'm very happy to share this part of our technology with you all. We'll kind of look at kind of the low-level details and then work our way up to seeing it live, like in our products. This is also our first webinar, so very excited to be able to show off here.
Awesome. All right. Well, I guess first things first, let's maybe explore the problem space for a few minutes before we get into any demoing of the CrossChain library. But yeah, so Connor, why is it so hard for companies and infrastructure providers to add blockchains in a reasonable time frame? Why is it typically a slow process?
Yeah, great question. It could come down to a number of details. Maybe like the blockchains are too new. There's not a lot of existing infrastructure, so the existing partnerships for providers to add support can take a while, as you're having to like rely on multiple stakeholders. Also, there can be like changes in obviously, like with different changes in how transactions are serialized, and depending on how the MPC protocol is integrated in the custody product, this can kind of cause like a lot of changes to have to be made. Not everyone has a very simple abstraction layer over the blockchain. So the more clean and more well-designed the abstraction layer is, then ideally, like the faster or easier it is going to be to add support for new blockchains.
Great. Okay. Yeah, I guess it makes perfect sense. And for those who've been around in the space for a while, will definitely know this is a pain point that's existed for some time now. So to that end, how does CrossChain solve this? Just from a high-level standpoint, what exactly is the CrossChain library, and how does it solve that problem of slow blockchain support?
So yeah, CrossChain is a completely open source library, and it is the sole component that is actually interacting directly with blockchains, whether that's making RPC calls, making these online requests, or even the offline steps where you're serializing a Bitcoin transaction, Ethereum transaction, and how that gets signed offline. Everything else in our product doesn't really care about any one specific blockchain. The completely abstraction is covered in this standalone library. It's even a tool you can use by itself. You don't have to use it as a library. You can compile it as your own kind of command line tool, cross-chain wallet, if you will. And that's a little bit what we're going to show in this webinar.
Okay, and we'll be looking very soon at the example of this new chain that you've been preparing, cooking up, ready to add to the CrossChain. But
Yeah.
I guess before that, one final question from me, and perhaps for the knowledge of everyone else in the audience, are there any prerequisites or any assumed knowledge anyone should have before engaging with the CrossChain library?
I mean, I suppose not a lot. I mean, it helps to know what an address is, how to look up an address on a blockchain explorer, very, very much the basics. But you don't need to. The nice thing about CrossChain, if you just want to use it, you don't need to know oh, is my blockchain account base or UTXO? How do the gas fees work? That's kind of all these low level details and differences between the chains themselves is handled. That is the implementation of CrossChain.
Excellent. With that, I will hand the floor to you, Connor. I will remove myself off screen temporarily so you can carry on with the demo.
All right, thank you. All right, I'll start just by showing off our GitHub repo a little bit. So if you, perhaps on your own time, look up CrossChain, it is written 100% in Go. You can install it locally and produce just a static portable binary that you can then use to create addresses and then transact either on testnet or mainnet for any of the 40 plus blockchains that we support. Now, this is a standalone program. It's not by itself a custody solution. So, the keys for your wallets, you can either put in a secret manager and an environment variable. It's kind of helps make this standalone. Also, if you look at the pull requests, as of last night, we added 2 new blockchains that I will be demonstrating. The first one is called Caspa, which is an up-and-coming new L1, layer 1 blockchain. It is what we call a UTXO blockchain, which I'll show a little bit what that means. And this is kind of has a brand new implementation for a blockchain. And then I also added Kava. And I added Kava because it is a Cosmos chain, and we already have, say, an existing support for Cosmos chains. So adding Kava, I'll just peek at it a little bit, is quite trivial. We're basically just adding configuration definitions for both mainnet and testnet. So that's what's the symbology for Kava, some on-chain identifiers, number of decimals for the native asset, that sort of thing. And I want to point that out because this does kind of affect the timing. So if we're adding a new blockchain for a driver we already have, normally we can get that out in the same day that we decide to add support for the chain. But for adding a new blockchain layer 1 like Caspa, that'll take us on the order of a week or 2, depending on how complex the chain is. So if you want to learn a little bit more about in detail about adding a new blockchain, you can look at either these pull requests or look at one of the ones that we've done in the past. Okay, so now I'm just going to talk a little bit. Oh, but if any of you have any questions, just type that in the chat of the platform and we'll kind of answer questions throughout the webinar. Okay, so what is the abstraction for a blockchain? At a high level, I like to break it down into these 5 steps. So the first step is kind of like actually being able to like create an address that you own, you can take custody of, and putting some digital assets onto that address. Right? That's kind of like the prerequisite to being able to transact. So with CrossChain, you can generate, if you can generate a random string of 32 characters, then you can generate an address for your chain with CrossChain, and then have a balance you can see. Now, to send a transfer, the user is going to have their own intent for what they want to transfer, like what asset I want to send, which address I want to send from, and where I want to send it to. This is kind of what we think of kind of like the your transfer intent, the very like high level. But then when CrossChain takes that intent, it needs additional inputs. So I kind of think about this as like the chain specific inputs, transaction inputs. It depends on what chain is being used, but normally it's like fetching some on-chain identifier to use for replay protection, or looking up the current gas fee estimation for the chain so that we can make a competitive transaction in terms of the fees. So once we combine that user intent with these on-chain inputs, we can actually do the offline step, the transaction lifecycle, where we serialize and sign it. So this is typically the most sensitive part of the process. In a real custody solution like Treasury, this is where policies would be in place. So like before you would sign anything, like you would want to be very sure your policies have passed. And then you want to sign it with a key that is secured. So like we use MPC wallets in Treasury. This can be done completely offline, no need for an internet connection or anything. But once that is done, the next 2 steps are typically very easy and it looks very similar across the different blockchains. You just broadcast it to the network and then wait for it to have enough confirmations or enough blocks to be produced. Okay, I will show this in action. I have a bit of a pre-recorded demo I'm going to talk over. First up, I'll show off our new chain that we added, Caspa. So here I have an address that's kind of derived from a secret I have stored in an environment variable behind the scenes. And I had added, this is on testnet, I used the faucet service that Caspa has and loaded up 1,000 Caspa. Now, to send a Caspa transfer, I'm kind of like typing into the CrossChain utility here my transfer intent. So I have like which key I want to use. I have the destination, the amount that I want to send. And this isn't going to send a full transfer. It's just going to do the first step where it's going to fetch the necessary on-chain inputs that we need to actually serialize and sign. So this is just that first like online step. And Caspa is a UTXO chain, like I mentioned, which basically means when you think about your on-chain balance, there isn't like a single entry for what your balance is. You actually have a list of these spendable resources that you consume for your transactions. In this case, my address just has one. I have one UTXO, and that resource has a balance of about just under 1,000 Caspa. So combining my user intent for a transfer and this on-chain input, I will be able to serialize and sign a transfer on Caspa, which I'll do here in a moment. Now, note here, this is not actually going to broadcast everything. I'm kind of specifying I want to do this offline. So it's going to serialize and sign the transaction. We're going to print it out. And I'm doing that just to demonstrate that this serialize and signing is done completely offline. And Caspa is just convenient here that they have a nice JSON representation of their transaction. I'm going to copy and paste this, and I'm going to use one of the RPC nodes hosted by the Caspa Foundation, and just like broadcast it manually, completely independently, just to show that this is a valid, signed, serialized transaction. We have a transaction ID here. Look at that on the Caspa Explorer. Caspa is very quick. You can see those confirmations just streaming in. Sent one Caspa. Okay. Now you don't have to like go through all these like manual steps, assuming you have everything set up. Like sending a transfer can just be easy. So I'm gonna like, here's another transfer, just doing everything like all at once using the CrossChain standalone binary. So you're just serialize and sign, send another transaction. It's just going to take a few moments for that to be able to download that transaction using RPC. Okay, there it comes in. See, by the time we downloaded, it already had 100 confirmations, 123. This format here is actually kind of nice because once we download a transaction that's on chain, we report it in a kind of a universal format. So it's easier for people that want to use this abstraction when they kind of report on all of their deposits or their transactions. They have just kind of one schema that they can use, and we're using it to report this Caspa transaction. If you have a transaction hash, you can also just download it manually. Here, actually, I made a mistake. I copied the block hash. Try that again, copy the actual transaction hash here. Now, if we download again, we'll see that it should have more confirmations. It doesn't have 123. It has just over 449. That's because we're downloading it live from the chain, and the chain, or Caspa, is adding new blocks very quickly. Okay. Now, real quickly, I'm going to show Kava, which is a Cosmos chain, and I just want to highlight the differences, like underneath the hood, like that CrossChain is handling. So I have a testnet address with about 100 Kava ready, and to send, I'm just going to show what the transaction input looks like for Kava for a Cosmos chain. Now, Cosmos is an account-based chain, doesn't have UTXO, so there's no like list of resources here. In fact, you don't even need to know what your account balance is. It's basically you need to know these like these sequence numbers associated with your address on chain. This helps protect from replay protection. So your transaction can't be like activated twice. You don't double spend money, which is very, very important. And then you also have some information on the fees. So this is like the current fee rate on Cosmos that would be competitive. And then that's yeah, kind of the differences under the hood that you have to define when adding a new blockchain. And when it comes to like the API level, sending a new transfer on Kava, it's exactly the same as on Caspa. So we'll send this transaction. And when it downloads, it's still in that same like kind of universal transaction format. We can see the balance changes for Kava, how many fees there were, and what's the current number of confirmations, just one. Cosmos chains are not quite as fast as Caspa, so we see the confirmations coming in a little bit slower. All right, so that's like the very like low level, very low level details of CrossChain. And by the way, like for these RPC calls, you can either you only need to have a stock RPC node, so you can kind of like use your own RPC service, whether you're running your own RPC or using QuickNode. We also have our a managed API. We call it the connector API, which is just a very thin wrapper around RPC nodes that we manage. And by using that, you don't have to worry about running your own RPC infrastructure. Okay, so now I just want to show how this works in a real like full custody product. So I'll switch over to our Treasury UI. So there's a lot going on here, but I'm just going to hone in on our Caspa addresses that I've kind of created behind the scenes. I think this one, look on the blockchain explorer real quick. So I have this address that has about 90 CASPA that I've set up beforehand. And so we'll see like what this looks like in an actual like custody product. So here I'm gonna kind of like input my user intent. I wanna send from one of my CASPA addresses to the other one. And I have a policy that I defined beforehand where I'm allowed to send internal transfers between this OTC trading desk account, which both of my addresses are in. So this should go through. Sending my CASPA token. I'm going to send 10 CASPA. So pretty simple. Now, you probably can't see this on the screen share, but I'm signing this request with a YubiKey that I have in my laptop. So our treasury behind the scenes, it's going to validate that it's been signed by me, Connor, and I have the appropriate role to do such a thing. The transfer policy also is passed. And the first state that we see this new transfer in is in preparing. That means it's going to like automatic behind the scenes fetch the transaction inputs to be able to ferry this new transaction along. And it's already succeeded because CASPA's pretty quick. So I'll look at this real quick on the Blockchain Explorer. Here's our new transaction. Has almost 600 confirmations already. Sending 10 CASPA. All right. And then real quick, I'm just going to do that again, but rather than, this is this policy. This is something you don't get by using CrossChain by itself. Because in CrossChain, you could send to any address, which is not secure, let's say. So here, I'm going to send to another address I have that is not in the OTC trading desk. And so I don't have a policy to allow this, to allow sending to this other address specifically. So if I were to send 10 CASPA again, this is not going to work. I'm going to sign it again with my credential. This time the policy wouldn't pass. You'll see the error here, the permission denied transfer policy did not pass. Very important that your custody solution basically has a way to like say no by default, and then we allow things specifically. And that's, in a nutshell, that's not what you're going to get by using CrossChain by itself. One of the many reasons you would want to take a look at Treasury. All right. Do we have any questions so far? Okay.
Quickly ask a question, Connor. Maybe just considering in the audience a few builders and people who are familiar with working with low-level blockchain infrastructure. How does CrossChain library differ to some other tools they might be used to, like Coinbase's Rosetta, another sort of open source tool which has got some traction in the market? Are there, what are the differences between CrossChain and Rosetta?
Yeah, great question. People may have heard of Rosetta, which is Coinbase's kind of like blockchain abstraction. Rosetta has a lot more detail and a lot more methods that have to be implemented, and it's also a kind of like a web server interface that needs to be implemented. So it's a lot more specific at getting blockchain support added in Coinbase, and it's not really you can't really use it as a standalone tool. So it's going to take a lot more effort to be able to add a blockchain, and you may not be able, you probably can't reuse it for other use cases outside of getting it added to Coinbase. Have a much, I think, in a much better world, we work with exchanges that use like our product to be able to take care of the full chain abstraction, so they don't need to use a Rosetta. And we have a much more simple abstraction through CrossChain to be able to add support for various blockchains in a much more like clear and easier way. All right. So yeah, if there's any blockchains that we don't have yet that you would like to be added, please just reach out to us. All right, Felix has a very good question. How do you add chains to the CrossChain library? I'll just reshare. So yeah, our CrossChain library is like open source. I have a couple pull requests here showing like kind of two different types of chains. Like one, like Kava is a Cosmos chain that we already have a Cosmos driver for. So adding that is kind of like just adding configuration definitions. And the other example is Caspa, which is like a brand new L1. Now, how do we make sure that there are no exploits or bugs? So I guess first and foremost, like CrossChain doesn't try to doesn't make any decisions on like, let's say like where your keys should be stored or where what kind of like policies are run. So this needs to be done like by a custody product, like it is done by Cordial Treasury on top of this. So like policies are checked, transaction inputs are checked. So there can't be an exploit where you're going to be sending to the wrong address because those inputs are all kind of fixed and checked by the surrounding custody solution that's using CrossChain. And as far as the sensitive parts, like actually like serializing the transaction, like we'll either kind of write how that is done ourselves, or we'll use a library that's published by the foundation, offered by the same people that run the chain.
Another question from me, Connor. So we looked here at adding the native coin or the native asset to these chains, Kava and Casper. Is there anything different you'll need to do if you want to work with a token standard on top?
Yeah, great question. All of our chain implementations include token support for the token standard on the chain. Sometimes the chain has like multiple token standards like Cosmos, and we'll try to include support for the various token standards that are on the chain. So as part of your, let's say the transfer intent from the user, if they can include like the contract address for the token, then CrossChain will handle making a transfer for that token. I'll show in Treasury real quick. You can kind of define tokens. So that's pretty much just define the simple, which chain your token is on, and then being able to set like the number of decimals and the contract address for that token on the chain. So like once you kind of define this in Treasury, then Treasury will kind of use this as an input to CrossChain to be able to create token transfers. It was definitely pretty important to basically allow users to add tokens themselves. There's no need. We don't need to be in the loop to add support for a token specifically.
How about with other transaction types? So we've looked at today sending some assets from a source address to a destination address. How would we potentially use CrossChain library to think about crafting a staking transaction or some other on-chain movement?
Yeah, great question. Yeah, we don't only do transfers, but we also cover staking for blockchains. We don't have staking for all of the blockchains, but we do have it for EVM, Cosmos, and Solana so far. going to quickly adding support for other chains like Sui and Aptos, and a few others. And this, we take advantage of the delegated staking model. So as long as the blockchain it's possible to do like delegated staking, then we have our abstraction also covers staking. Okay, well, if any other questions, please type them out. I think maybe we can start wrapping this up. If you want to check out CrossChain, please just go to our GitHub repo, you can install the utility. You can try just having a command line CrossChain command line wallet. You can try out the staking. If you're interested at all in trying out Cordial Treasury, it's very easy. We can set this up very quickly for you. Just reach out to Seb or I or marketing. You can even schedule a demo, and we'll kind of like have a much more in-depth guided tour of our Cordial Treasury product. And as well as you have any interest in just reading about more in detail about our APIs, more advanced use cases around Treasury, some of the other resources that we support, we have everything documented on our documentation. We have various guides and API references.
Yep, and I guess to reiterate again, for anyone who wants Sandbox access to a testnet version, you can send that to marketing@cordialsystems.com, or like Connor mentioned, reach out to one of us and we will get that sorted for you. And you can try out your cross-chain work directly in a wallet, such as Cordial. Otherwise, all that's left to say perhaps is the stream will be made available for sharing. If anyone couldn't make it or you want to share with colleagues, we of course welcome any feedback and hope to do more of these educational sessions as we touch upon all things Cordial and supporting digital asset infrastructure. So thank you, Connor. That was a great demonstration. Good to see 2 new chains are going to be going live now for our customers. So we'll have to get on the socials and post about that. But yeah, great stuff. Thank you everyone for joining today, and we'll hopefully see you soon.
Yeah, thanks everyone. Thanks for joining our first webinar. Hope to have more in the future.